exhaust porting plays a crucial role in the performance of turbocharged engines. By carefully shaping and smoothing the exhaust ports, airflow is improved, allowing exhaust gases to exit the combustion chamber more efficiently. This optimized flow reduces back pressure, which helps the turbocharger spool faster and operate more effectively. As a result, the engine can produce more power and operate at lower temperatures, enhancing both performance and reliability. Proper exhaust porting is a key step in unlocking the full potential of any turbocharged setup. Traditional exhaust porting methods focus on smoothing and enlarging the exhaust passages to improve airflow and reduce back pressure in naturally aspirated engines. Techniques such as gasket matching and removing casting imperfections are commonly used to enhance exhaust gas evacuation. However, when these methods are applied to turbocharged setups, their effectiveness can be limited. Turbo systems rely on exhaust gas energy to spool the turbine, and excessive porting may actually reduce the velocity needed for optimal turbo response. As a result, traditional porting approaches may not always yield the desired performance gains in turbocharged applications. In naturally aspirated engines, exhaust gases exit the combustion chamber and flow directly out through the exhaust system, driven solely by the pressure created during combustion. In contrast, turbocharged engines route these exhaust gases through a turbine before they leave the system. The energy from the exhaust flow spins the turbine, which in turn drives a compressor that forces more air into the engine. This process not only alters the pressure and velocity of the exhaust gases, but also creates back pressure, affecting overall engine performance. As a result, exhaust flow dynamics in turbocharged engines are more complex, with the exhaust energy being harnessed to boost power output. Carbide burrs are versatile rotary tools commonly used for shaping, grinding, and removing material from hard surfaces. Among the various shapes available, large tree-shaped burrs stand out for their ability to tackle aggressive material removal tasks. Their unique design allows for efficient cutting and smoothing of contours, especially in metalworking and woodworking applications. These burrs are ideal when rapid stock removal is needed, making them a preferred choice for professionals seeking both speed and precision. Preparing exhaust ports for turbo applications requires careful attention to airflow and efficiency. Begin by thoroughly cleaning the exhaust ports to remove any carbon buildup or debris. Next, use a large tree burr attachment on your rotary tool to gently shape and smooth the port surfaces. Focus on removing casting imperfections and creating a consistent, streamlined path for exhaust gases. This method, often referred to as the large tree burr hack, helps optimize flow and can contribute to improved turbo performance. When working with carbide burrs for porting, safety should always be the top priority. It's essential to wear protective gear, including safety glasses, gloves, and a dust mask to guard against flying debris and fine particles. Using a high-quality die grinder with adjustable speed control allows for precise and controlled material removal. Secure the workpiece firmly in a vise to prevent movement during operation. Regularly inspect your tools for wear and ensure proper ventilation in your workspace to maintain a safe and efficient environment. Aggressive exhaust opening techniques are designed to maximize engine performance by allowing gases to exit the combustion chamber more rapidly. This approach can improve power output, especially at higher RPMs. However, it's important to avoid common mistakes such as opening the exhaust valve too early, which can reduce cylinder pressure and overall efficiency. Careful timing and proper adjustment are crucial to ensure optimal results without causing unnecessary wear or loss of power. By understanding these principles, you can achieve a balance between performance and engine longevity. Improved exhaust scavenging plays a crucial role in enhancing turbo spool and overall engine performance. By efficiently clearing exhaust gases from the cylinders, scavenging allows fresh air and fuel to enter more rapidly, creating optimal combustion conditions. This process helps the turbocharger receive a stronger, more consistent flow of exhaust energy, enabling it to spool up faster and deliver boost sooner. As a result, the engine experiences reduced turbo lag and increased responsiveness. Ultimately, better scavenging contributes to greater power output and improved efficiency across the entire power band. The shape and size of an exhaust port play a crucial role in determining how efficiently a turbocharger operates. A well-designed exhaust port allows exhaust gases to flow smoothly and quickly toward the turbo, minimizing turbulence and back pressure. If the port is too small, it can restrict gas flow, reducing the energy available to spin the turbo and decreasing overall efficiency. Conversely, if the port is too large or poorly shaped, it may slow down gas velocity, also impacting turbo response. Achieving the right balance in exhaust port design helps maximize turbocharger performance and engine power output. Optimizing exhaust porting for high boost and high flow turbo setups requires careful attention to detail. It's important to smooth out any sharp edges or casting imperfections within the exhaust ports to reduce turbulence and improve gas flow. Enlarging the ports should be done conservatively, maintaining the original shape to preserve velocity, which is crucial for efficient turbo spool. Matching the exhaust ports precisely to the manifold gasket can help eliminate flow restrictions. Additionally, ensuring a consistent surface finish will further enhance exhaust gas evacuation, supporting better turbocharger performance under demanding conditions. When porting exhausts for turbo engines, it's important to avoid removing too much material, as this can weaken the structure and lead to cracks under high temperatures. Uneven surfaces or sharp transitions can disrupt exhaust flow, reducing efficiency and potentially causing turbulence that affects turbo performance. Using the wrong tools or techniques may also introduce stress points or leave behind debris that can damage the turbo. To ensure durability, always use precision tools, maintain smooth transitions, and verify that the exhaust retains sufficient thickness for strength. Regular inspection and proper heat-resistant materials further help maintain long-term reliability. In summary, optimizing your engine with turbo-specific porting techniques can lead to significant performance improvements. By tailoring your approach to the unique airflow and pressure demands of turbocharged systems, you unlock greater efficiency and power potential. Remember, careful attention to detail during the porting process ensures the best possible results. Embrace these specialized methods to maximize the gains from your turbo setup and elevate your engine's performance to the next level.